participants, welcome to this webinar. This webinar has been organized by Breakit Project, which is founded by 80 raw materials community, which is a part of European Institute of Technology. Breakit Project, bringing knowledge to exploitation, a T-shaped itinerary approach, proposed a training to help researchers and the other technical professionals to transform their knowledge generated in R&D project into innovation to the market. In this project, we are collaborating with 8 European organizations. Speaking is Teresa Sessa. Okay. The schedule is the following. First part of the structure is 10 minutes on metal recovery. Second part, 30 minutes, are on a study case regarding Crocodile project as the efficient example of recovery of cobalt with innovative integrated leading technologies. At the end, other 10 minutes for question and answers, where you can post your questions in the feedback area. Okay. Cobalt has an exceptional high temperature strength, corrosion resistance, catalytic properties, and exceptional strengths for electrochemical properties, which make it a crucial element for high performance applications where European Union is in the leads. For example, electrical power generation turbines, cobalt magnets, chemical industries, and oil refineries. The largest market share of cobalt is batteries. About 50% of overall current cobalt demand worldwide, estimated at 1,000 tons annually, is related to the production of lithium-ion battery cathodes, which in turn are powering the current boom in electronic vehicles. Each electrical car battery requires between 4 to 11 kilograms of cobalt. Cobalt is used in many applications that support the shifts to a low-carbon economy. Therefore, the demand of cobalt is rapidly increasing, and its price. The price of cobalt has risen nearly 250% in 2017 and is expected to significantly increase in coming years, driven by stricter emissions controls that push the global demand for electric vehicles. As a result, the European Commission considers cobalt as critical raw material. Currently, Europeans import about 65% of this cobalt, approximately 10,000 tons per year. Only 35% is produced from secondary sources, such as recycling of spent battery, superalloys, and hard metals. Whereas in 2017, 65% of the world cobalt mine production, about 1,060 tons, was enough to satisfy the global demand. The latter is expected to skyrocket in the next decade. According to the JRC report, under average conditions, demand will outgrow supply by 64,000 tons in 2030. Though its supply risk, economic importance, and the current absence of the value substitution, cobalt has been classified over the past years by the European Commission as critical raw materials. It is crucial to secure adequate cobalt supply, which are obtained substantially. In the vision of alternative solution, cobalt recovery plays a key role. More efficient examples on recovery of cobalt are based on use of novel integrated leading technologies, such as Horizon 2020 Crocodile project. In this webinar, we would suggest Crocodile project as a case study in which the combination of innovative methodology allows for a smart recovery of cobalt for a large variety of resources. The project Crocodile is funded by European Commission. It will showcase innovative metallurgical systems based on advances pyro, hydro, bio, and ino and electro-metallurgy technologies for the recovery of cobalt and the production of cobalt metal and upstream products for a wide variety of secondary and primary European resources. The overall project objective is to demonstrate on a large scale novel economically and environmentally viable metallurgical system integrated different technologies for the recovery of this material, cobalt. The other main aims are demonstrate scaled up innovative integrated system and technologies capable to assure the efficiency and of existing raw materials recovery processes. Develop a new mobile system with capability of production cobalt metal to enable new business opportunity and expand the business across European Union. Build a strong value chain capable of supplying approximately 10,000 tons of cobalt per year, about 65% of current European Union demand, from mainly European resources. 24 partners are involved in this ambitious project with a different task. We can see recyclers like Relight and Stena, an important research institute, another important engineering company like Idner, and the other are shown in this slide. The waste collector partner supply of new secondary resources rich of cobalt to 4 European partners responsible of physical treatment, setting up of conditions for the collection of secondary resources rich in cobalt at a massive scale in Europe. Different co-bearing sources like lithium batteries, electric vehicles batteries, and cobalt catalysts are processed into a high-quality cobalt concentrate by applying a unique combination of advances mechanical, wet mechanical, and pyro-mechanical processes. During this phase, a black mass with high concentration of cobalt oxides and cobalt metal and the other metals such as steel and nickel will be produced. In mining operation, cobalt can be leached from primary sources using bio-leaching and extraction of metals from ores using living organisms. Finally, the high-quality cobalt concentrates from the primary and secondary sources are further processed using solvent extraction and electrowinning, which allows a selective extraction of cobalt. Along this cobalt, other valuable materials like lithium and graphite are extracted too. Different innovative metallurgical systems are used depending on the properties of the elements in the waste stream. Physical-chemical properties such as a melting point for pyro-metallurgy, solubility for hydro and solvometallurgy, and electrical properties and conductivity for electrometallurgy. All the above-mentioned processes will be optimized and combine them in a compact commercial mobile system with a production capacity of up to 200 kilograms of cobalt metal per day. The technical concept of the unique crocodile recovery process is based on integrating of two micro areas. Firstly, pre-treatment, in which advanced physical treatment solutions are developed, such as first mechanical, then wet mechanical, and at the end pyro-metallurgical solution for the production of high quality of black mass rich in cobalt. Second area, chemical treatment, in which black mass will be produced with several cutting-edge chemical engineering solutions. As illustrated in this figure, there are two main routes, respectively processing primary and secondary material with coverage into final step. Primary route, where the input is laterite, is based on bioleaching. The metal contained in laterite and mixed sulfuric oxide ores are released and solubilized with a bioleaching step using living organisms. From the results solution, selective precipitated of cobalt and nickel sulfides will be produced and then processed in the next and final step. Secondary route, where the input are batteries, catalysts, and V, is based on leaching with a new type of green solvent. So-called deep eutect solvent, DES acronym. The black mass produced in this pre-treatment phase will be processed in the leaching reactor with DES, produced from low-cost, no-toxic naturally occurring chemicals and recovered and reused in closed loop. The leachate will feed the pyro-metallurgical step, which will operate the separation of the metal from the DES phase by extracting them directly in the cobalt chloride or sulfite phase. Will be used as a direct input for electrowinning step. The final step, this electrowinning technology, involves low pressure and temperature. It means low operational costs. On top, the electrolyte can be easily recycled and reused for the whole process. Final output of the whole route after electrowinning phase will be cobalt metal. In the following slide, primary and secondary route in detail to show different processes and the partner related to each step. The four supplier are Stena, Relight, and Monolito with different secondary feedstock. For example, Relight is responsible for spent batteries, consumer battery, Monolito about catalysts, and Stena about vehicle batteries. This kind of feedstock will process in physical treatment and then in leaching. Instead, primary feedstock comes from mining operation, in which are responsible companies like Lerco and BRGM, was processed in bioleaching. Then both feedstocks will be processed in liquid extraction and the final step, electrowinning, in which is responsible SINTEF. Second phase of this project will be focused on the identification of the best chemical routes and the optimization at an intermediate scale plant. So, bioleaching of cobalt will be optimized and upscaling using a 100-liter bioreactor. Electrowinning will be optimized and combined in a compact commercial mobile system with a capacity to up of 200 kg of cobalt metal per day, means 50 tons per year. This system could allow European industries to test a new way to recycle cobalt for their available resources without having to do a large investment in the plant. The company responsible on the hosting of the pilot plant is Eco Recycling, Italian company. Crocodile benefits are reduced drastically the supply risk of cobalt for European industry, lower energy cost and environmental impact, providing solution with a low capital investment cost, maximize the exploitation of local waste, everything through a great methodology that takes into account health, safety and environmental risks. Crocodile project will develop a detailed market analysis and business model based on process efficiency, metal stock exchange, and market share, and an engagement strategy with investors. Together with the Crocodile Consortium, these stakeholders will make the best possible practices so then an environmental and socially responsible business model will be developed and a future replication of projects concept can be ensured. Thank you for your attention. And now we are ready for the last session on question and answers. Every participant is free to make a questions. Thank you for your participation in this webinar. Breakit has also online courses related to technical topics in raw materials like material substitution, recycling, and material chain optimization. Will be available for audience through this open learning platform on Mondragon website. Thank you.